All right, this begins the second lecture on solving systems. So I'm going to solve this system with you, and I'm going to leave this one entirely up to you, and then I'm going to solve a couple more systems where we have a special linear inequality in two variables where it only contains one of the variables. So we're going to see a vertical or a horizontal boundary line. So starting with this one, the first thing that we have to do in order to to graph this or to solve it is to put it in slope-intercept form. So we see y is less than or equal to negative 2x by moving this 2x over to the right-hand side. So my y-intercept in this case is the origin, and so I'm going to place that on the origin, and then from there I'm going to use my slope to get two more points. So rise 1, 2, run negative 1, and label that point. X is equal to negative 1 and y is equal to positive 2. Come back to the y-intercept, down 2 and to the right 1. Label that ordered pair and then graph the line. This is going to be a solid boundary line because my ordered pairs, or excuse me, because my inequality has equality in it, so solid boundary line. I totally missed those points, so you'll just have to pretend it goes through there. And then I'm going to be shading based upon checkpoints. So my checkpoints below the line is going to be my first one because I see in slope-intercept form this says less than. So I don't have the origin to use this time because the origin lies on the line, so you can't use anything on the line, remember. So I'm going to choose 0, negative 1. That's below my line. And so this is below. And what we're going to see when we put that back into the original, remember the original equation, so y is equal to negative 1, and then plus 2 times my x, which is 0, and that's questioning whether that's less than or equal to 0. And we see negative 1 is less than or equal to 0, which is a true statement. And then what we want to do is we want to check the one above it, the checkpoint above the line, and the checkpoint above the line that I'm going to use, again, I can't use the origin, right, because the origin's on it. I'm going to use 0, 1 this time. And so putting that in, we have, oops, I'll just do it here. We have 1 and then plus 2 times my x, which is 0, less than or equal to is what we're questioning, 0. And this says 1 is less than or equal to 0, which we see is false. And so again, we're going to shade below this line. So we're just going to shade in over here just like this. And then put my equation on the line so I know what this represents. And then I am off to graphing the second one, which I'm going to do in a different color, of course, because I want them to show up in contrast to one another. So this one we have 5x plus 3y is greater than negative 2. So I'm going to put this in slope-intercept form by solving it for y. So 3y is greater than or equal to a negative 5x minus 2. And then divide by 3, divide by 3, divide by 3. And so now I have that y is greater than or equal to a negative 5/3 x minus 2/3. Now what we see here is that the y-intercept is not an integer ordered pair. So what I'm going to do to solve this one is I'm going to put in an x equaling a negative 1. And when I do that, I see that y is greater than or equal to negative times a positive, or negative is a positive, so I have 5/3 minus 2/3. And you see what that gives me is 3/3. And 3/3 is equal to 1. So what I just found there was an integer ordered pair. X equals negative 1, y equals 1 is a solution on the boundary line. And that boundary line is going to then be able to be graphed not with a difficult ordered pair that contains a fraction. So now I'm going to go use this negative 1, 1, so x equals negative 1, y equals positive 1, as my starting point for graphing that line. Okay, so once I have that ordered pair, then I'm going to use the slope to get to 2 more points, and I'll finish this in the next video.